Welcome back! In the last few lessons, we've been concentrating on confidence intervals. We learned about two situations, when the population variance is known, which happens very rarely in practice, and when the variance is unknown and follows a student's t-distribution. The goal of this lesson is less about learning and more about clarifying. All right, these are the formulas that allow us to find confidence intervals. As we noted in our previous lecture, these parts are the ones that determine the span of the confidence interval. There is a special name for these expressions, margin of error. When the population variance is known, the margin of error is equal to this expression. And in the case of population variance unknown, the margin of error is equal to this expression instead. So, basically, the confidence intervals could be summarized as follows. The true population mean falls in the interval defined by the sample mean plus minus the margin of error. Now we get to the core of this lesson. Getting a smaller margin of error means that the confidence interval would be narrower. As we want a better prediction, it is in our interest to have the narrowest possible confidence interval. The best part is that we can control the margin of error. Let's see its parts. There is a statistic, a standard deviation, and the sample size. The statistic and the standard deviation are in the numerator, so smaller statistics and smaller standard deviations will reduce the margin of error. How do we do that? A higher level of confidence increases the statistic. A higher statistic means a higher margin of error. This leads to a wider confidence interval. Think about this example. You took an exam and you want to make a prediction about the mean grade obtained by all exam takers. As A, B, C, D, and F are all the possible grades, we are 100% confident that the mean grade will be in the confidence interval from F to A. Now, if we lower the confidence level to 99%, we may end up with a confidence interval from F plus to A minus. Remember the interpretation? In 99% of the cases, the population mean falls in the interval. So, with a 50% confidence level, in 50% of the cases, the true mean will fall in the specified interval. The only scenario under which this is possible is if the interval is narrower. Therefore, if the standard deviation and the sample size are kept constant, a lower confidence level will result in a narrower interval. What about the standard deviation? That's easy. A lower standard deviation means that the data set is more concentrated around the mean, so we have a better chance to get it right. For instance, the mean grade in your class is B, and you know that there were people with A's, B's, C's, D's, and a few F's. How likely is it that you got a B? Now, compare this to a situation when the teacher said, the mean of the class is around B and the lowest grade is C. In this case, you are much more likely to get a B, right? In the first case, the grades are dispersed, while in the second, they are concentrated. Lastly, we have the sample size in the denominator. Higher sample sizes will decrease the margin of error. This is also quite intuitive. The more observations you have in your sample, the more certain you are in the prediction. This time, you have a B+. There are 30 people in the class, and you want to know if you performed above the average. You ask 3 of your friends, and they all got A's. Your sample of 3 people leads you to think you underperformed. You get frustrated and start asking around some more. The next 5 people you ask got D's. Now you have a sample of 8 people, and it seems you did quite well. After asking everyone in class, the whole population that is, you find out that the mean grade is B. You are above average by a small margin. The conclusion is that the more observations there are in the sample, the higher the chances of getting a good idea about the true mean of the entire population. All right. Hopefully, this clears up some doubts you may have had. Thanks for watching.